needs just in a minute. All right. So what is ADAS? ADAS stands for Advanced Driver Assistance System, ADAS. So it's a form of autonomous driving technology, all right? Now, which actually encounters some bumps in recent months. For example, the permit of GM's Cruise to operate its robot taxis in San Francisco was pulled. Google's Waymo recently issued its first ever recall because some of its robot taxis collided with some pickup truck. But there was good news too. Waymo was given the permission to operate its robot taxis on high-speed roads in Phoenix, Arizona. So the lessons from all these developments are the following. First, level 2A+, level 2 ADAS is still the sweet spot that every major car manufacturer is still focusing on, level 2 ADAS. So that's one. Second, the main challenge of developing a robust ADAS product is how to comprehensively and cost-effectively stress test the exception handling capability of the ADAS system's core engine. Is how you do this test. That's the name of the game. So how do we do this stress test? Ideally, the simple answer is to be able to generate millions and millions corner test cases, like really real test cases that can expose the weakness of the ADAS system under test. That's really the name of the game. So imagine that we have an ADAS system at hand, like this. And let's assume it's an open pilot, which is an open source ADAS software. So that's actually open source ADAS software. That's actually pretty high quality, right? And then we have two things called vehicle dynamic simulator that simulates the vehicle that is under the control of this ADAS system. So you need a simulator for the vehicle. And you need a virtual environment simulator, which simulates the virtual world in which this ADAS system is supposed to operate in, right? Everything is done virtually in the computer. So you need something like this. So then, given this, what is called COTA? COTA is the test case generator that supposedly generate these millions and millions of corner test cases, and then play them in the virtual environment simulator. That's what COTA is supposed to be, generate these test cases. But it does more. It can actually, based on the test result and runtime log, to provide the following three types of feedback for each test case exercised against the ADAS system under test. First, it can tell whether the ADAS system passes or fails a test. So that's easy, like when you take an exam, your professor tells you you pass or you fail. That's what it means. Second, if the ADAS system fails a test, it can tell you which part of the ADAS system, the perception engine or the control engine, that's responsible for the failure. So it's like when you take an exam, the professor can tell you that this part of the material you are not very familiar, that's why you fail, okay? And the third feedback is that if the ADAS system fails a test, it provides a remedy to help the ADAS system to get better and eventually pass the test. That's the thing that we really want, right? The reason you want to take a test is you want to know where your weakness is. The reason you want to know your weakness is you want to get rid of it. You don't just want to know the weakness without getting rid of it. And that's what COTA eventually is designed to do. So I'm going to describe that just in a bit. So, in order to explain this concept, let's take a specific ADAS functionality called Adaptive Cruise Control, ACC, as an example. In ACC, you have at least two cars. The ego car, which is under the control of the ADAS system, is supposed to catch up with the car preceding it, the leading car, right? And until the distance between the two is reduced to a certain value. And after that, it tries to maintain this distance regardless of the speed of the leading car. That is, if the leading car speeds up, then the ego car should speed up. If the leading car slows down, then the ego car should slow down. Okay, so that's how ACC works. Now, imagine you are an ADAS testing engineer, and you are supposed to generate a test script for ACC. That's your job. So first, you have to use COTA's editor to specify what we call logical scenario for that test script. In that logical scenario, it's going to describe the set of vehicles involved in the test. In this case, minimally 2 cars, the ego car and the leading car. And then you would describe maybe the initial distance between the two, maybe the speed profile of the leading car, and so on. So that's what you specify first as a logical scenario. In addition, you specify the road environment, the road on which these vehicles are going to run on, right? Whether, how many lanes does this road have? Whether this road is straight or curved, and what's the degree of curve? Whether there's a turn, whether there's an intersection, and the intersection is a T section, Y section, roundabout, and so on, right? That's a road environment you have to specify. Now, this is where COTA does its magic. By enumerating all possible valid combinations of the parameters associated with the logical scenario, the road environment, the weather condition, the times of day, and the lighting effects, it's going to generate all possible legal valid combinations, right? So each resulting combination now corresponds to a test case. Right? So that's how you generate this test case. So this slide shows, sorry. Go back, oh. Go back. And forward. Oh. So this slide shows sort of multiple example test cases generated from the same logical scenario and road environment. But we vary the times of day, the weather condition, the lighting effects, and so on. As you can imagine, there's a lot of parameters you can vary. So if you have like a 20 parameter, each parameter has like 5 possibilities, then you do the math. There will be a large number of variations or combinations that you can produce. So now, once we generate, COTA generates these test cases, it's going to exercise each test case against the ADAS system under test, right? So this is the first case. It's a simple case. It corresponds to a noon time on a clear day, right? So the visibility is good. And the ADAS system under test does what ACC is supposed to do. It tries to catch up with the leading car, and when the distance is at a particular distance, it maintains the distance throughout. So it passes the test. Along the way, COTA also provides some detailed execution statistics so that we can analyze what's going on. For example, it provides something called error in the distance estimate between the ego car and the leading car. So there's a distance, and the ADAS system is estimating that distance. And because we know the ground truth, so we can show the error between the ADAS system's estimate and the ground truth. So that's that error. And then it also shows the time and the extent to which the brake was pressed. When was the brake pressed, and how hard it was pressed is also shown in the third figure, right? So that's what COTA can provide. And with that, we can analyze the second case. It's also a noon time, but on a heavy, foggy day, a lot of fog. So the visibility is very poor. But the same logical scenario. As you can see, the ego car eventually ran into the leading car because the visibility is very poor. So by the time it detects the leading car, it's too late. It's too late. And therefore, it fails the test. Now, if you examine the error plot, it seems that the error of the distance estimate is much higher than the previous case. That's the reason, because there's a lot of error in estimating the distance. And also, as a result, the brake was pressed too little, too late, and leading to the eventual unavoidable collision, and therefore it fails the test. So now we know the reason, right? Now in the next case, it's also a clear day. The visibility is also good, but for some reason, the ego car cannot recognize an obstacle lying in the middle of the road, and eventually ran into it, and therefore fails this test, right? So turns out that this obstacle is an overturned truck that lies sideways across multiple lanes. So this is a very unusual scenery for a ADAS system. And the perception engine of the ADAS system cannot recognize this overturned truck. Why? Because it was never trained with images of this kind of object during its development. It never sees anything like this, then of course it cannot recognize this. Now, knowing that this is the root cause, that the perception engine of the ADAS system is the subpart that's responsible for the failure, and the reason it fails is because it cannot recognize this kind of object. Kota says that maybe we can generate additional test cases similar to this one, but contains a lot of these overturned trucks. For example, like this. So the first one, you show that immediately there will be an overturned truck, but lying in a different direction. And this one, then you will see an overturned truck on the side. And then this one. So when you drive, you don't see anything, but when you make a turn, you see another overturned truck. Now, Kota generates these additional test cases, and then use these additional test cases to retrain the perception engine of the ADAS system. Once this retraining is done, it then retests this retrained ADAS system with the same test that it previously failed, and this is what happens. So of course, sure enough, this retrained ADAS system is able to successfully recognize the overturned truck and stops properly without colliding with it, and therefore eventually passes the test. Remember I say, the reason you take a test is because you want to know your weakness. The reason you want to know your weakness is because you want to get rid of it. So Kota not only can expose your weakness, we can also help you to correct that weakness. That's why Kota is so unique. So what's the big deal of Kota, you might ask? So we started the development of Kota with the aim to generate as many corner test cases as possible to stress test an ADAS system. That was what it is set out to do. What we set out to do is something like this. But later on, we figured out that we can actually do much more. We can actually do much more. By carefully analyzing the detailed log of the execution of a failed test, Kota can actually learn a lot. In particular, it can pinpoint the specific deficiency in the ADAS system under test of why it fails that test, and the part of the test case that exposes this deficiency. Two things. Which part of the ADAS system that causes this failure? Second, which part of the test case that exposes this deficiency, right? So now armed with this knowledge, Kota is able to generate additional test cases that can be used as remedial training material to help the ADAS system under test to correct the corresponding deficiency and get better, right? So in other words, whenever Kota is able to successfully generate a test case that the ADAS system fails, it can identify the deficiency responsible for the failure, and it can provide a remedy to correct or remove the deficiency, and then repeat the loop. I claim that it is the Kota's capability to completing this test, identify problem, remove problem, test, identify problem, remove problem loop that uniquely pushes beyond the state of the art in ADAS testing. That is, to our knowledge, there's no other ADAS testing can do anything like this. Okay? So eventually, under Kota, when ADAS system fails, the more tests ADAS system fails, the better it is going to get. This is somewhat sort of like a paradox, but that's what happens. Like the more tests you can fail under Kota, the better you are going to get. Right? So finally, we all know that AI